Hello students, welcome to today's lecture on compiler design. So in our previous class we have discussed about the specification of tokens and recognition of tokens, which are major building blocks of lexical analysis phase. And then we have seen how to generate the actual implementation of lexical analyzer with the help of the specification of tokens and recognition of tokens. And we have generated some sample C code also for one of the identifiers that we have considered during the specification and recognition of tokens. So it is always possible that you can write the actual C code for the entire lexical analysis phase if you are capable of. But then there is a facility available to generate the lexical analyzer. Remember this. There is no need to write the entire code of lexical analysis phase. It is possible to generate the code for implementation of lexical analyzer with the help of a tool called as Lex. So that is what our topic is today: lexical analyzer generator tool, which is nothing but the Lex. Okay, so we'll discuss about it today. So Lex is a program that generates lexical analyzers automatically. So we don't need to write it in our own. Automatically, the Lex tool generates the lexical analyzers implementation in C language. So generally, this Lex tool is available with the platforms, the operating systems in Unix or Linux platforms. So it is directly available as a command Lex, and its most recent version, which is also Flex, which is nothing but fast lexical analyzer generator tool. Flex is also available with the recent Lex, Unix and Linux platforms. Uh, this Lex tool is actually written by these two authors, Eric Smith and Mike Lesk. Okay, the role of this lexical analyzer generator tool is to read an input stream specifying the lexical analyzer and outputs the source code implementing the lexical analyzer in C programming language. So our task is now reduced. We don't need to write the C programming code for implementing the lexical analyzer, but the task is reduced to just specifying the lexical analyzer. Okay, so for implementing a lexical analyzer, we need two steps. What is it? One is to specify the tokens with the help of regular expressions, and then recognize those tokens with the help of a simulated finite state automata, which is then converted into the C language code. With the help of this lexical analyzer tool, what is reduced is we just need to know how to specify the lexical analyzer with the help of regular expressions, but you don't need to know how to write the C programming code for recognizing the tokens. The Lex tool automatically generates uh, that recognition of tokens with the help of the specified tokens in the form of regular expressions. So what is remained here, what is our task reduced here? We need to specify the lexical analyzer components with the help of regular expressions, and then this tool takes this specifications in the form of regular expressions and produces the actual lexical analyzer, which can identify the tokens of a language, and the code will be in C programming language. Okay, so Lex tool will read the patterns which are specified in the form of regular expressions, then produces the C code for a lexical analyzer that scans for identifiers or any valid lexical unit. So that is what the job of Lex tool is. Okay, and let us consider a simple pattern for recognizing the identifiers. Say letter, a single letter followed by any combination of letter or digits, full star. Clean closure says that any combination of letters or digits, zero or more occurrences, right? So a single letter is considered as a valid identifier, and also followed by it, you can have any combination of letters and digits. Okay, so this is called specifying the regular expression for particular token called as identifier. And once you write this regular expression in your Lex program, then automatically these regular expressions are translated by the Lex tool into a computer program, probably in C language, that mimics the finite state automata, that is finite automata, to understand or to recognize the tokens that satisfies this regular expression. Okay, so we reduce the burden of writing that mimicking finite state automata in C language. We are just sufficient to write the regular expressions that represents every single token represented by a language. Okay, so this pattern matches a string of characters that begins with a single letter followed by zero or more letters or digits, and you need to specify all those patterns in the programming language in the form of regular expressions. And we supply these regular expressions to the Lex tool, and finally it produces a C program which can recognize all those tokens that matches this pattern. Okay, so that is what Lex is. You need to understand some matter pattern matching primitives to when you are writing regular expressions. When you write a dot, it means match any character except that new line character, which is slash n. If you write slash n as your meta character, then it means matching with the new line character only. If you say star, it means zero or more copies of the preceding expression, whatever before appears before the star. Then plus says that one or more copies of the mm, preceding expression before plus. Question mark says that zero or one copy of the preceding expression, and this cap symbol represents that starts with notation, starts with. So cap followed by, if you specify any pattern, it matches with any string that starts with the corresponding string which follows this cap symbol. And dollar is used to write end of the string matching. That is dollar followed by, if you write some pattern over here, it always it always matches with the end of the line. Whenever it finds a match with the end of the line, then it is a proper match, and mm, performs the corresponding action. This pipe symbol specifies that the preceding one or the second one is A or B. The meaning is A or B, and you can write any number of characters over there separated by pipe symbol. And this AB plus means that one or more copies of AB. That means AB, 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 and so on. This is a string literal, simply represents a string, a constant. And finally, when you want to combine more than one character, you use this pair of angle brackets, which are used to represent a character class. So these are all the meta characters used in Lex programs. And let us understand the meaning of some of the expressions. If you write ABC, it means ABC only. There is nothing else. If you write ABC star, because star is a unary operator, which is applied on C only. So AB is going to be common. AB followed by zero or more occurrences of C. It says so AB, ABC, ABCC, ABCCC, and so on. And ABC plus says that one or more occurrences of C. So ABC minimum one time C must appear. ABCC, ABCCC, and so on. This says that BC plus says that one or more occurrences of BC. So A is compulsory, followed by BC. Any number of times BC appears in the string. And what about this A followed by BC question mark? BC might appear 0 or 1 times. That means A followed by nothing and A followed by BC. Only these two matches will be found. This says that exactly one of A or B or C. You can write it as A pipe B pipe C also. This A hyphen Z means that all the symbols between A to Z, and A backslash hyphen Z says that three characters, character A, character hyphen, character Z. When you want to include this hyphen as a match character in the character set, then use this escape sequence slash backslash. So backslash hyphen means find a match for hyphen also. So only three characters are matched. Again, this is hyphen AZ, which is going to be same as this one. This says that capital A to Z, small a to Z, 0 to 9 plus one or more occurrences of any of these combinations, alphanumeric characters. And this is one or more appearances of white spaces. Slash t is a white space representing tab. Slash n is a new line character representing another kind of space. Okay, one or more, and this is a blank space. So either blank space or slash t or slash n represents a white space. And this says that starts with AB, anything except A comma B, and A followed by B with a cap is going to be either of those characters, those three characters, and A or B is one of A or pipe or B, and finally without the double this angle brackets, A or B represents that one of those two, either A or B. Okay, so try to remember these two representations. If you put it inside a angle bracket pair, then it means this pipe symbol is also a possible character. Otherwise, it's going to be separate A and B. Okay. Now, look at the structure of a Lex program. It consists of three parts. One is definition section. Second one is rule section. This is going to be a mandatory part. This is an optional part, and the second one, C code section or subroutine section, is also optional. So what is compulsory over here? The rule section is compulsory. In definition section, we write all the manifest constants, declarations of variables, initialization of variables, and also including some library files and all. You can write down in definition section. A rule section specifies that a pattern followed by its action. So rule section always contains pattern, action, pace. So a pattern always represents a regular expression. Action specifies what is to be done when that particular pattern is matched. Okay. So rule section is very important for defining your lexical analyzer. And C code section or subroutine section implements the functions which are used by this rule section. So for example, when a pattern matches, if you are calling a particular function, that function must be defined in this section only. You should not write the function definition over here. Just call the function here in rule section and define the function in subroutine section. Okay. Remember that rule section is always put inside a pair of percentile symbols. Okay. So beginning of rule section is two percentile symbols, followed by ending of rule section is again two percentile symbols. So this is what the structure of a Lex program is. It consists of three parts: definition section, in which the initialization part is done; rule section, where the pattern and its corresponding actions are defined; and the code section, which contains the subroutines or functions used by the rule section are defined. Okay, and there are some predefined variables and functions available with Lex. You need to understand this. YYLex is a function which is called from main to invoke the actual lexer. Okay, so we write this function in every Lex program inside the main function. This invokes the lexer actually, so we need to write it again. And YY text represents the matched string till now, the pattern which is matched till now. So it contains the corresponding string which is matched, and YY is the length of the string which is matched. YYL value is the left value associated with the corresponding token. YY wrap is wrapping up all the matches. Returns 1 if the matching is done successfully, otherwise it returns 0. YY out is the file where the output of lexer is written, and YY in takes the input file, and initial is the initial starting condition of the lexer, and begin is the condition switch start condition. Echo writes the matched string onto your screen. Okay, so these are the predefined variables. Almost in every program we use YYLX. If you want to display the matched strings, you can use YY text, and if you want to display the length of the string, you can use YY length. In every main function we write YY wrap and YYLex. Okay, sometimes we make use of these files if you want to see what is written by your lexers. Okay, now have a look at this program to understand how the Lex programs are written. So in the first part, it is writing digit, it is defining the digit to 0 to 9, and letter to capital A to Z. a small a to z. And in the definition section, it is saying int count. It is declaring only the count variable because this is a global part. It is automatically initialized to 0. There is no need to write it, or else you can write it as int count is equal to 0. And in matching part, that is rules section, this is the pattern. Pattern is letter. Uh, how it is defined is any letter followed by digit plus plus. Okay, so this is saying that this entire pattern is saying that if anything like this is found, what is it saying? A single letter followed by any combination of letters or digits. This is saying a regular expression for identifier. This is a regular expression for identifier. Whenever this is found, then we are defining a action here. What is that action? Count plus one. So this is the pattern and this is the action. Initially count is 0. Whenever an identifier which matches this, count plus plus will be done. Okay. And finally, we define the main function in auxiliary section. Immediately, we call YYLX to generate the Lexer program. And after Lexer program is identified, Lexer calls the corresponding source program and identifies all these identifiers which matches with this syntax and performs this action count plus plus. Finally, it comes back. Then you defining this printf over here because it's a C program. Number of identifiers is equal to percentile d comma count. Return 0 to indicate the successful completion of your program. So what it does is whatever source program is given as input to the Lex program, it counts the number of identifiers in the program and displays it with the help of this function printf. Okay, all right. Look at one more example here. Uh, I'm declaring two variables and initializing them to 0. Char count is equal to 0 and line count is equal to 0. So I want to find out total number of characters in a C program and the total number of lines in a C program. I just want to count them. So therefore, I declare two variables to 0 here. And in rules section, this dot indicates that if you remember that table, the dot pattern indicates that match any character except the new line character. Match any character except the new line character. So what we are doing here, uh, dot says that match any character. So if you find any character from the source program, just increment the char count plus plus. So char count is initially 0. So whenever it matches with this dot, then it increments the corresponding char count by 1. Okay. And because dot will not consider that slash n as a character, you need to write it again. So whenever there is a match with slash n, it means a line is generated, because whenever slash n is observed, you are moving to the next line, that is second line. So therefore, line will be incremented by 1, and also slash n is a character, char count is also plus plus. Why we are doing it here? Because dot will not match the slash n. Except the slash n, every other character will be counted over here. Slash n need to be counted separately. Okay, so whenever there is a slash n identified, one line will be incremented and one character will be added. Okay, so these are the patterns and the corresponding actions. And dot is the pattern which matches with any character. Then the action is char count plus plus, and slash n is the pattern we are looking for, and the action is line count plus plus followed by char count plus plus. Two actions. Okay, and then we define the main function. YLX calls the Lexer program. It will implement all the Lexer program, and then this rule section will be utilized by your Lexer. Whatever source program you send to the Lexer program, it will count all the lines and characters in the corresponding source program. Okay, then when it comes back, it continues with the statement printf there were percentile d characters in percentile d lines. So you are defining this function to display the number of characters and number of lines. So first percentile d displays the number of characters, char count, and the second percentile d displays the number of lines, which is in line count. Okay, and return 0 indicates the successful completion of your program. But then you might have a doubt how to run these Lex programs, right? So let us have a look at how to run these Lex programs. Say you wrote this program, you wrote this program in a notepad editor, or in Linux, you will open this with vi space some file name .l extension. So the program which you write as a Lex program must be saved as any file name .l extension. .l is compulsory. You can pick any name for the file. Okay. So this is done in Linux with the help of vi space counting.l, vi space counting.l, and then typing this entire code into that counting.l. Okay. So once the program is written in counting.l, the second step is uh, you you are always in Linux command prompt. After writing this, you will come back to the command prompt by typing :wq, right and quit, by saving the counting.l program and coming out of the corresponding editor. Then you will come back to Linux command prompt and then use this command. There is a command called as Lex, and in latest versions the command called as flex is also available. So either Lex command or flex command you can use, followed by the file name counting.l. So if you type this command Lex followed by the counting.l, this will produce a file called as lex.yy.c. This name is going to be same whatever program you write. This is the output of your Lex program. Okay, Lex compiler. So Lex invokes the Lex compiler and takes this Lexer program counting.l and produces a C program with same name lex.yy.c. So if you write other program with let us say example1.l also, if you submit it to Lex, it is again going to produce lex.yy.c only. So whenever you invoke Lex with any file, it is always producing lex.yy.c file. Okay, and then because this is the C file which is representing the Lex program, compile it with the help of C compiler. So cc space lex.yy.c. Then you will get a ./a.out file which is ready for execution. Then use that ./a.out file and submit any C program to it, so that it produces the corresponding required things written in counting.l or any other Lex program. For example, if you submit this program, let us say counting.l, then what it produces is uh, in example.c, it counts all the characters and all the lines and produces the number of characters and number of lines as the output. That is, there were, for example, 100 characters in 15 lines. The output may be like that. Okay, so that is how you can execute a Lex program. Okay, so remember these steps and try to execute these programs if you have Linux operating system in your laptops, or else you can execute these programs when you come back to the college, when you go to lab in offline mode. Okay, so that's all for today. If you have any doubts with the lexical analyzer generator tool, that is Lex, you can contact me at snreddy.biram@gmail.com. I will definitely reply back to you. Okay, and I request all of you to write a few programs to count. Let us say this is the program to identify the number of identifiers, to count the number of identifiers in a program. Similarly, you write the number of keywords in a given program, and also you try to write the number of operators in a given program, and so on. Try to identify the number of different possible tokens in a given C program. Okay, that is your task. Try to write programs in your own. Okay, thank you. That's all for today. Uh, and this is the last topic in your first unit. When we come back, we will discuss about uh, the second unit. Okay, so that's all for today.